All right, here we go, chemistry kids. It's scientific notation review. This should sound familiar from math, I hope. If it's not, hope this little review will get you going on this and get you in the right direction. So scientific notation, what's the generic form or the general form? It's going to be some number, okay, so some number, that's my number sign, times 10 to whatever power, all right? And that's your general form, so it's times 10 to whatever. And then moving on to part two, how many digits can be in front of the decimal? So for this number, it might have a decimal, it might not, but the key is it can only have one number in front of the decimal. An example, 2.1 times 10 to the third, okay? You can't have 21 times 10 to the fourth, it's got to be 2.1. You always have one number in front of the decimal and one number only. Positive exponent, so exponent would be this, and this number goes to here. If this exponent is positive, that tells you that the number is bigger, or depending on what you're doing, you're going to have to move the decimal to the right. That's a bad arrow, but we'll work it out. You move the decimal to the right. However, if the exponent's negative, it doesn't mean it's a negative number, it just means the number is smaller. Or if you're moving the decimal, you're going to move the decimal to the left. All right, so let's see if we can apply how these things kind of get into. So this gives you a general idea of your scientific notation. So try a couple of these, and then if you want to stop the video right now, try these by yourself, see if you can rearrange them, and then we will then I'll go over the answers. So here's the answers for these ones. If you want to stop the video and do it yourself, this one is going to be 8.8 times 10 to the, let's see what we got, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the ninth, and don't forget your label, no naked numbers. So it's a positive number. Notice how the number's bigger. All right. And then this next one, it's going to be 6 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, sorry. Negative 11, and it's going to be kilograms per meters cubed. All right. Moving on to this one, now you got to draw it out in longhand version. So a negative 8 tells me the number gets smaller, so that means I got to move the decimal to the left. And what I should have is I should have 0. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. I should have 7. 593 grams. All right, and this next one, because the number is positive, that means the number is going to get bigger. So I move it to the right. So you go 1, 2, 3, and it should be 2,500 centimeters. Okay, so notice how significant figures and accuracy is maintained. Here I have 2 sig figs, 2 sig figs, 1 significant figure, 1 significant figure, 3 significant figures, 3, 2, and 2. So always maintain your accuracy and precision when you're writing those numbers down, and that has everything to do with significant figures. So there's a review of scientific notation. Hope that helped. Watch maybe some other videos, or try to get some examples done on YouTube, but that's your general review. All right, we'll talk to you later.